All right, our second topic in chapter 5.2 is writing polynomials. So here, if I give you something in factored form, you need to be able to write it in standard form. So it's just a matter of distribution. So to keep things in order, you're going to FOIL out the first pair of binomials first. So I ignore the x plus 3 that just tags along at the end. And then I am going to combine like terms. Now all I'm doing is distributing the x to everything in there, and then distributing the 3 to everything in there. So since there were 2 terms here and 3 terms there, I should have 6 products down here. Now I combine all my like terms. Why does that say x squared? Hold on. Should be there we go. And that is our solution. The you try will be after the next example, and we'll give you a couple problems to do. So now, what if I tell you to write a polynomial, but I don't write it out for you, I just tell you what the roots are. So if we have roots at -2, 3, and 3, well, since x equals -2 is a root, that means x plus 2 must be a factor, because if we set x plus 2 equal to 0, x equals -2 would be the root that solves that. We're always going to go with the simplest factor that would be solved by x equals -2. So the factors must be x plus 2, x minus 3, and x minus 3. Because if we plug a 3 in, that gives us 3 minus 3 is 0. That makes 3 a root. So there's our function. And now we got to distribute. So we're going to FOIL out the first and combine like terms, giving us this. And then we distribute the x to everything. And then distribute the -3, make sure you include the sign, the -3 to everything. And then we combine as many of those 6 terms as we can. And that gives us this as our function. All right? Now notice that those 3's are repeated. When a factor is repeated, or when a root is repeated, it's said to have multiplicity. Multiplicity of the number of repeats. So if it repeated twice, it's got a multiplicity of 2. If it repeated 3 or 4 times, it'd be a multiplicity of 3 or 4. This is just writing what I said, multiplicity of 2. Now notice what happens on the graph. We're finding the roots or solutions, which are x-intercepts. At x equals -2, it crosses the graph. When I had a multiplicity of 2, it actually just kind of bounced off the x-axis. So when we consider end behavior and where our function's increasing and decreasing and multiplicity of roots, once we put all this stuff together, we're going to be able to graph pretty much any polynomial. All right, here are you try problems. And I'll expect to see those in class next day.